of distillation method approaches. The simple distillation. In the simple distillation, we have seen that the liquids which got very wide differences in the boiling point, we will be able to separate them. And because the period of the time it is taking, we are making a small adjustment and modification and made it to a process where the entire quantity is equilibrated at once, and they will be getting separated in the distillation. This is one. And the fractional distillation and the rectification, we have seen that when boiling points are not widely spread, so they will be able to separate by keeping a fractionating column or rectification column, and we are able to separate them into individual fractions, even though that boiling points are separated. All the fractionating columns or rectification columns, we need to keep in between your still and condenser. So we have seen the concepts behind how to separate them, but we have got one problem in this particular case is azeotropic mixtures. They will not be able to separate by this particular approach because they are constant boiling. Say for example, if you have got A and B both are boiling at 99, so you will get in fractional distillation also same product. In that particular case, we cannot use this fractional distillation. We need to use azeotropic distillation. In the azeotropic distillation, we are adding a third substance, and that third substance is forming a new azeotrope and breaking the original azeotrope and making one of the components free, and it will be getting distilled. So the same simple distillation will be working now to get separation of two liquids which are having a constant boiling point. So by adding a third substance, we are doing it. So in all the cases, we are heating our liquid at the higher temperatures equivalent to boiling point. So we want to reduce the boiling point to safeguard our material degradation. So we are using a vacuum distillation or distillation under reduced pressure. In the distillation under reduced pressure, you are reducing the atmospheric pressure so that your boiling point will be reduced. So this is the approach we have seen. Additionally, we need to use a vacuum pump. So this is the industrial setup for the vacuum distillation. So another approach what we have discussed is steam distillation. In the steam distillation, we have seen that the boiling point can be reduced by using a vacuum, but without using vacuum, we are using a steam. It will contribute some vapor pressure, so that this vapor pressure of a steam and along with the liquid vapor pressure, it will be made to 760 mmHg. So the liquid will start boiling at the lower temperatures than their boiling points. So this is the approach also versatile. We use for eucalyptus oil, turpentine oil, and preparations like aromatic waters. We will be using this. And we have seen additional which we need to have. This is a steam generator. So in your examination, you are going to be asked with each steam distillation or any distillation setup, what are the specific part which you need to introduce for the functioning of that particular system. Say for example, in vacuum distillation, you need to use a vacuum pump. In the steam generator is required. In azeotropic distillation, you need to add a third substance which are required to be added. So these are all the specific which you are making it a distinct distillation process. So in all the cases, what we have seen is they are all batch processes. Till now, whatever we have seen is a batch process. Because we want to make the process continuous, we have started with a molecular distillation. We introduced this topic in the common section A, section B. Now we are getting separated. So we're going to take this topic. This topic is very important in our pharmaceutical purposes because we are going to have many times this process involved in separation of critical natural products from a high boiling point fixed oils. So this is being used. So the definition is concerned, this distillation process molecule in the vapor phase travels mean free path. I hope just going to reduce the distance between your still and condenser less than the short mean path. This is actually a free mean path or short path. So the short path is the critical length. Below that length, the liquids vapor will not collide with each other. They will not come back as a reflux. This is actually a critical concept. So I repeat, we need to condense the vapors before free mean path. Before free mean path means the distance which is traveled by the molecules without collision with each other, whatever the distance we need to calculate, and the distance we are going to make the condensation taking place. So this is actually a basic principle. So the substance to be distilled have a low vapor pressures. That is the reason these boils at the high temperatures. Example like viscous liquids and oils, greasy, waxy materials, high molecular weight substances. These are all, they will be having a low vapor pressure, and boiling point which are having near to the 300 degrees centigrade also, we are going to use them in this process. So now the question will come, how to calculate that free mean path or the distance which we need to adjust, because this is a versatile equipment. This equipment has got a variable distance we can adjust between the condenser and your still. So there is a formula which is given. This formula is used for the calculation of mean free path. That is lambda is equal to 3 by rho in P all to the power of 1 by eta. In this particular case, rho is density, is vapor pressure of that liquid what we are taking in our distillation process, and eta is the viscosity. So when you are having this data with us, which can be collected from the standard literature that is available for the products, so we will be taking them, the pressure and viscosity. We feed in this particular formula. When you replace it and calculate it, so you are going to get the free mean path, the distance, how much between your condenser and your still. Generally, it is in mm to centimeters it will be present. So we are making adjustment with that in such a way that the short mean path will be met. Before short mean path, the condenser will be placed. So the vapors are condensed back to your product. So this is a major concept. And we are going to have two types of the equipment for this particular molecular distillation. These are all very, very important questions for your sessional examination and final examinations. And they are all the frequently used in natural products division. So we are going to use in practice also. So do memorize this, and you are bound to get an examination frequently. Most probably, probability is there to get this in the exam. So the first one is wiped film molecular still. In the wiped film molecular still, you are having the feed which is present at the top. So the feed which is present here, the feed which will make the cursor is actually disappearing, so I am not able to see, but I will mention through the oral. In the top right hand side, you have got a feed which is entering. So the feed, when it is entering, it will be wiped by the wiper from the right. You are seeing from the right side the vertical lines which are present. Wiper is a blade-like structure, just like your spatula. You have got a knife-like structure. So this will be moving around your surface of your still, making the film formed very thin. So the thinness which will make the faster operation and also increases the surface area. So the feed is entered and the wiper is making a thin film formed. So you are having a jacket that is having slant lines. You are seeing in this diagram in extreme left jacket. The jacket is circulated with hot oil, oils or water, and making your distillation receiving some heat input. So this jacket is providing heat input. So the wiper is wiping out the liquid feed into a thin films, and it is moving by the rotor, so making the film formed. It makes the heat supply. After sufficient heat supply, what will happen? You bound to get a vapors. So to be condensed before. Now you are getting a horizontal line here. The horizontal line, whatever you are finding here, it is a condenser. So that condenser liquids, and it will be allowing to fall down, taking it as a product in the bottom. Okay. So the remaining liquid, which is non-volatile in nature, that will be received as a residue. So that residue will be collected separately. It means your feed is separating into two fractions. One is your product that is coming from the condensate, and the another is a residue which is leftover material from. Okay. So the thin film, which is after completion of your evaporation, which is leftover material, non-volatile material, that is actually a residue you are getting it. So this is the concept which is making a versatile in this particular case, because you are going to use the vacuum pump. This vacuum pump will reduce the boiling point, but we have already seen in the vacuum distillation, when you are reducing your atmospheric pressure lesser than atmospheric pressure, your boiling point will also be reduced equally. So not linearly, it will be reduced. Say for example, in the case of, take the example of glycerin. Glycerin may be having boiling point of 290, and at 290, it is producing 760 mmHg vapor pressure. When 760 mm vapor pressure is exerted, and glycerin will start boiling. That is the concept of boiling point we have got. But when you are having a temperature of 125, the glycerin will produce only vapor pressure of only 1 mmHg. It means if you reduce your atmospheric pressure from 760 mm to 1 mmHg, your liquid will start boiling at 125 degree centigrade itself. So 125 centigrade is a good one, because our thermolevel substances, they will not be getting degraded at this lowest temperature when compared to your boiling point. So this one makes your reduction in the boiling point safeguarding your thermolevel substances. So this is the advantage you are going to gain in this particular equipment. And if you see, in all the cases what we have seen previously, they are all batch processes. But this is a continuous process. Why it is a continuous process? You are feeding your liquid from the top, and you are making the liquid to come down as a product and residue because of the gravity. You are not using any pump here. Just by allowing the gravity, you are allowing to get the feed separated into two. One is residue, another one is a product. So whatever the product residue value you are getting from the bottom, that much rate you are feeding at the top. So your process will be continuously going on without pausing or without any skipping your stopping or pausing your equipment. So this is actually a versatility which you are going to get it, and it is also a compact manner. But you are going to have a rotor. That rotor is rotated by the motor. So the rotor is attached with the wipers that will make the thin films. So if you have got a thin films, the effectiveness of your heating and formation of the vapors are very high when compared to your regular one, because this thin film will be completely getting wiped. So you don't get to bound to get any gaseous interface between your still surface. Two equipments are present in the molecular still. That is centrifugal molecular still. In the centrifugal molecular still, you are going to have a centrifugal effect that is making your liquid moving from bottom to up. Previously, what we have seen in the wiped film molecular still, it is coming the feed from the top to bottom by the gravity. But here what we are going to use, we are feeding the liquid. If you see left side from the bottom, it is having a feed. That feed is, it is going to have here, and it is moving, and it is moving up and going to have like this, and it is falling into the center basket. The basket is continuously it is moving. Because the basket is moving, the centrifugal effect makes the center to periphery. So the liquid is pushed from the center to periphery. So when it is pushed to, liquid will not have any place to go. It bound to move up. So around the basket, the liquid bound to move up. The feed liquid is going to move up in the form of a layer. So in this particular case, the wiper will not be present. That is replaced, and we are having a centrifugal effect that is allowing the thin film to be formed. Because that is having continuously, it is getting fed by the pump, and you are going to get and moving at in a thin layer into the top of this particular equipment. So you are got a heater. That heater will be supplying the heat energy that makes the liquid to get boiled. So the liquid, when it is getting evaporated, the evaporated liquid will be condensed again. So we need to adjust the distance between this and this. So we are adjusting from the still surface to the condenser. This is lesser than your free mean path. So this free mean path concept, it will allow you to make your process taking place without any reflux, and you are making efficiency of your process, and product will be, yield will be very high. So once your liquid is getting completely formed in a condenser, and it will be collected in the tray that you see here, it is a tray is present. So this tray will be making filling of your received liquid. You are going to get it a product. So here it is mentioned as a residue, but it is going to be a product. Then the leftover material will go into the top here, and that will be received as a residue. So this is also a continuous process, and you are feeding your liquid from the bottom, and by the centrifugal effect it is moving up. Because of the heater, it is getting heated, and you are getting vapors. So the vapors are condensed in the condenser, and you are going to collect as a product, and the leftover material which is required to be coming as a residue, which is non-volatile in nature, you are collecting. So you, in this also you have got a vacuum pump setup. If you see, it is present at the top. So that makes the removal of your atmospheric pressure, reduction in the atmospheric pressure, creating the vacuum. So reducing the boiling point. Because it is reducing the boiling point, you are having low temperatures, your distillation process is going on. And when low temperature distillation is going on, you are going to have a safeguarding your components from the thermal effect. So thermolabile substances can be protected. So in this particular case, where we are going to apply these equipments, that is the question which we are going to have. This is applicable in the separation of your, if you see the application part of it, purification of chemicals like a triacetyl, trichrysyl phosphate and dibutyl phthalate and dimethyl phthalate. So they are having the boiling points are very high, but still we are able to separate them by using this methodology at a reduction in the temperature by applying the vacuum. We can also separate vitamin A and vitamin E of fish liver oils. Vitamin A and vitamin E are non-volatile in nature, so they will not be coming to the condenser. So you are getting residue. So the remaining fixed oil is separated by the condenser effect. So you are able to separate them. And we are going to use the most frequently in the fixed oils. They are having high boiling points. So it is also used to separate the fatty acid mixtures. So this is also being used versatilely to separate your components of pharmaceutical interest from your fixed oil. If you see here, in particular case of the molecular still, your vitamins are coming in the case of molecular still here in the residue side, and the remaining fixed oil is coming in the product, that is the condenser side. So this is actually what you are going to, which product which you are going to see. Similarly, in the centrifugal centrifugal molecular still, what will happen? Your product is your vitamin A and vitamin B, that is non-volatile in nature. That is the reason it is a residue side. So that you are taking it as a product. So the product which is formed in this diagram, it is given as a alternatively. The product place you named as a residue place it is given as a product, but you interchange it. So the residue is sometimes which is required material to us. Sometimes the product is required material. In the case of vitamin A and vitamin B, we are going to have a residue is actually critical to us. The remaining thing which we are going to use it for the. So we are going to give. It is an extension of learning you want to have, when compared to your regular learning which is present place. So you are going to have this. In the destructive distillation or a dry distillation, the method is in which the distillate decomposition product of the constituents of organic matter burnt in the absence of the air. That is the reason we are calling it the pyrolysis. So here solids are also there. It involves the heating of a dry organic matter. That is either it is a root or any material which is having some shape in a suitable vessel in the absence of air until all the volatile substances are drained out. It is used to obtain many valuable products from the wood, coal, and animal matter. So this is actually what you need to know before we are winding up our session. So another one is the compression distillation. In the compression distillation, we have got, it is used to meet the needs of Navy and Army for the fresh water, which is obtained from the sea water. So it is water is quite pure and pyrogen free.